Hello to everyone. In the last video, we have to seen the case of two-dimensional heat equation, and in that part, I will already said that when we have the steady state case, that is the case of Laplace equation. So, in this question, in this part, in this video, we will discuss about solution of Laplace equation. So, let us consider a question. Question is solve del 2u over del x square del 2u over del y square is equal to 0. 0 is less than x is less than pi and 0 is less than y is less than pi, which satisfy the conditions u of 0 comma y is equal to u of pi comma y is equal to u of x comma pi is equal to 0 and u of x comma 0 is equal to sine square x. So this is the question. This is the question we have to solve. This is the problem of Laplace equation. Del 2 of x, del 2 of u over del x square plus del 2 of u over del y square. This will equal to 0. This Laplace equation is a well-known example of in the field of mathematics, which we discussed in the vector analysis also, in physics also. This Laplace equation we have already aware about this equation. Now we have to solve this equation by method of separation of variable on the basis of this condition. So, in solution, let u is equal to capital X into capital Y be the solution of given partial differential equation. Solution of given partial differential equation, where x is function of x only and y is function of y only. Show by method of separation of variable we have del 2 of x over x del x square plus of del 2 of y over y del y square, this will be equal to 0. This implies that del 2 of x over x del x square is equal to minus of del 2 of y over y del y square, this will be equal to minus of k square. This will be equal to minus of k square. So this k square we have to let, ये हमने let किया है. This be the equation number 1. ये equation number 1 हो गया. So we have del 2 of x over x del x square is equal to minus of k square, and in this side del 2 of y over y del y square, this will be equal to minus of k square. This implies that x is equal to c1 cos of kx plus c2 sine of kx. and this capital Y is equal to C3 e to power ky plus C4 e to power minus of ky. Show the complete solution of the given Laplace equation is u of x comma y is equal to c1 cos of kx plus c2 sin of kx into c3 e to power ky plus c4 e to power minus of ky. Alright, so this will be the equation number 2, and this is the solution of given partial differential equation. But in this equation c1, c2, c3 and c4 are unknown constant. So we have to obtain these constant values by substituting the given initial condition. So we put x equal to 0, u equal to 0 in above equation. We have 0 is equal to c1 c3 e to power ky plus c4 e to power minus of ky. This implies that c1 is 0 since c3 e to power ky plus c4 e to power minus of ky is not equal to 0. This is not equal to 0. क्यों? क्योंकि we have to substitute the value of x. So this c3 e to power ky plus c4 e to power minus of ky is not equal to 0 because this is the function of y only. So c1 is 0. Show equation 2 becomes u of xy c2 sin of kx c3 e to power ky plus c4 e to power minus of ky. Now we put x equal to pi, u equal to 0 in above equation. So 0 is equal to c2 sin of k pi c3 e to power ky plus c4 e to power minus of ky. This again is not equal to 0 because this is the function of x only. When c2 is 0, then the solution will be trivial, so we cannot take it 0. So this implies that sin of k pi is equal to 0. This will be sin of n pi. This implies that k is equal to n. So this is the value of n. So show equation 3 becomes u of x comma y is equal to c2 sin of nx c3 e to power ny plus c4 e to power minus of ny. Now we put pi of u equal to 0, y equal to pi in above equation. So u of this with the 0 sin of nx c2 c3 e to power n pi plus of c2 c4 e to power minus of n pi. This implies that this implies that a e to power n pi plus b e to power minus of n pi, this be equal to 0, where we take c2 c3 is equal to a and c2 c4 is equal to b for our easiness. So this implies that a e to power n pi is equal to minus b e to power minus of n pi. This implies that this be equal to minus of 1 upon 2. For our easiness we will take it this. So a is equal to a is equal to minus 1 upon 2 b e to power minus of n pi, and b is equal to 1 upon 2 b e to power n pi. So putting value of a and b, we have u of xy is equal to sine of n pi to b e to power minus of n pi e to power ny plus 1 upon 2 b e to power n pi e to power minus of ny. This be equal to 1 upon 2b e to power n pi minus y minus of e to power minus of n pi minus y sine of nx. This will be sine of hyperbolic n pi minus y sine of nx. This will be equal to summation of bn sine hyperbolic n pi minus y sine of nx. This is the u of xy. Now we substitute the last initial condition. This will be equation number 5. Now we put y equal to 0, u is equal to sine square x in equation 5. We have sine square x is equal to summation of n equal to 1 to infinity bn sine of hyperbolic n pi sine of nx. Here bn sine of hyperbolic n pi is equal to 2 upon pi 0 to pi sine square x sine of nx dx. So this will be equal to 1 upon pi integration 0 से pi plus cos of 2x sine of nx dx. This will be equal to 1 upon pi integrate by simplification 0 to pi sine of nx 1 upon 2 sine of n plus 2x plus of sine of n minus 2x dx. On integration we get 1 upon pi minus of cos nx by n plus cos of n plus 2x upon 2 times n plus 2 plus cos of n minus 2x upon 2 times n minus 2 0 to pi. On substituting the value, we have 1 upon pi cos of n pi by n cos of n plus 2 pi upon 2 times n plus 2 plus cos of n minus 2 of pi upon 2 times n minus 2 and minus minus हो जाएगा प्लस 1 upon n 1 upon 2 times n plus 2 1 upon 2 times n minus 2. On substituting the given initial condition, we have to obtain this result. Now on the simplification, we get this be equal to 1 upon pi minus minus of 1 to power n upon n plus minus of 1 to power n plus 2 upon 2 times n plus 2 plus of minus of 1 to power n minus 2 upon 2 times n minus 2 plus 1 upon n 1 upon 2 times n plus 2 upon 2 times n minus 2. This be equal to 1 upon 2 pi 1 upon n plus 2 plus 1 upon n minus 2 minus 2 upon n into minus 1 to power n minus 1, this bracket 1, where n is not equal to 2. दिस इज द सोल्यूशन. ये हमारा सोल्यूशन हुआ जो कि वैल्यू किसकी है बी एन साइन हाइपरबोलिक ऑफ एन पाई. बी एन साइन हाइपरबोलिक ऑफ एन पाई. दिस इज द वैल्यू ऑफ बी एन साइन हाइपरबोलिक ऑफ एन पाई. So this implies that Bn sin hyperbolic n pi this be equal to minus of 8 upon pi n square minus 4 when n is odd. When this value of n is odd, when this value of n is odd, so when it will be odd, this will be minus. So minus plus 2 times and n is not equal to 2 to 3 5 1 5 1 and minus 2 upon 3 15. No, sorry, when it will be minus 1 to power n, so when n is even, oh yeah, sorry, yeah, it will correct. When it will be odd, it will be minus, and when it will be minus, then minus plus. Okay, and this will be 0 when n is even. When n is even, then this term n ka power minus 1 ka power even, then it will be positive, and when it will be positive, ये plus हो जाएगा, ये minus हो जाएगा, so it will be 0. So there is this case कि Bn sin hyperbolic n pi is equal to 0 when n is even, and when n is odd, it will be this. But here one more things I want to mention, that n is not equal to 2. So this equation is valid for n is greater than 2. This case is valid for n is greater than 2. So b square sin hyperbolic 2 pi this be equal to 2 upon pi 0 to pi sine of square x sine of 2x dx. So this will be equal to 1 upon pi 0 to pi 1 minus cos of 2x sine of 2x dx. This will be 1 upon pi 0 to pi sine of 2x minus 1 upon 2 sine of 4x dx. This will be equal to minus of cos of 2x by 2 plus 1 upon 8 cos of 4x 0 to pi, and this will be 0. This implies that b square is 0. So this will be the equation number. This will be the equation number. ये 5 हमने दे रखा था 5, so this will be 6 and this will be 7. On putting the value of bn from 6 in 5, we get u of x comma y, this be minus of 8 upon pi summation of sin nx sine of hyperbolic n pi minus y upon n square minus 4 sine of hyperbolic of n pi for n is odd, that is 3, 5 and so on, because n is not equal to 1 नहीं होगा, क्योंकि ये 1 हमारा जो है हमको ग्रेटर देन 2 लेना है. So this is the process of to solve Laplace equation. Further we have see the example of transmission line in my next video. Okay.